In this video, we are going to determine gel point in step polymerization using Flory-Stockmeyer statistical approach. Determine the gel point extent of reaction at which gelation occurs using Flory-Stockmeyer statistical approach for the various ratios of reactants below. Phthalic anhydride and glycerol in the ratio 1.5 is to 0.95. Phthalic anhydride, glycerol and ethylene glycol in the ratio 1.5 is to 0.8 is to 0.15. Phthalic anhydride, glycerol and ethylene glycol in the ratio 1.5 is to 0.5 is to 0.8. So Flory-Stockmeyer equation is here. 1 over square root of R times FWA minus 1 times FWB minus 1, where R is the feed ratio and R is less than 1, and FWA and FWB are the weight averages of the functionalities A and B. Now, in the first case, we have phthalic anhydride and glycerol in the ratio 1.5 is to 0.95. So, let's first try to find out the feed ratio. Phthalic anhydride has 2 carboxylic acid, so the functionality is 1.5 times 2, which is 3. Glycerol has 3 hydroxyl groups, so the functionality is 0.95 times 2 times 3, which is 2.85. So since 3 is greater than 2.85, for finding R, we want to put 3 in the denominator because R has to be less than 1, and 2.85 in the numerator. So we get the feed ratio as 0.95. Now let's find out the functionalities. The functionality of carboxylic group is, the weight average functionality of carboxylic group would be 1.5, which is its number of moles, times 2 squared because there are 2 carboxyl groups, over 1.5 times 2. Similarly, the weight average functionality of hydroxyl group is going to be 0.95 times 3 squared divided by 0.95 times 3. Okay. So if we do the calculation, we get the functionality of carboxylic group to be 2 and the functionality of OH group to be 3. Plugging this into the Stockmeyer's equation, we get Pc equals 1 over square root of R, which is 0.95, times 2 minus 1 times 3 minus 1. And that gives us a Pc value of 0.7071. Moving to the next part, we have phthalic anhydride, glycerol and ethylene glycol in the ratio 1.5 is to 0.8 is to 0.15. So let's find out the functionalities. For phthalic anhydride, that would be 1.5 times 2 carboxylic acids, which would be 3. For glycerol, it would be 0.8 times 3 hydroxy groups, which would be 2.4. For ethylene glycol, it would be 0.15 times 2 hydroxyl groups, and that would be 0.3. So the total hydroxy group is 2.4 plus 0.3, which is 2.7. So again, the carboxyl group functionality is more than the hydroxyl group functionality. So for finding the feed ratio, we are going to say R equals 2.7 over 3, which is 0.9. Now let's find out the functionalities, weight average functionalities of the carboxyl group. So FW of carboxyl group is 1.5 times 2 squared over 1.5 times 2. So this gives us 2. Weight average functionality of hydroxyl group is 0.8 times 3 squared plus 0.15 times 2 squared divided by 0.8 times 3 times 0.15 times 2. So this is going to give us 2.89. To find PC, PC equals 1 over square root of R, which is 0.9 times 2 minus 1 for the carboxylic group and 2.89 minus 1 for the hydroxy group. And PC comes to 0.7667. Now, the last part. Here, the ratios of phthalic anhydride, glycerol, and ethylene glycol are 1.5 is to 0.8 is to 0.5. So the functionalities are for phthalic anhydride 1.5 times 2, which is 3. For glycerol, it is 0.8 times 3, which is 2.4. And for ethylene glycol, 0.5 times 1, which is 0.5. So the total hydroxy functionality is 2.4 plus 0.5, which is 2.9, and the carboxyl functionality is 3.0. So we have carboxyl functionality in excess, and that would be in the denominator for finding the feed ratio. So the feed ratio would be 2.9 over 3.0, which is So for finding the feed ratio, we are going to say R equals 2.7 over 3, which is 0.9. Now let's find out the weight average functionalities of the carboxylic group. That would be 1.5 times 2 squared over 1.5 times 2, which is 2. And the weight average functionality for the hydroxyl group would be 0.8 times 3 squared plus 0.15 times 2 squared over 0.8 times 3 plus 0.15 times 2, 2.89. So PC equals 1 over square root of R, which is 0.9, times 2 minus 1 times 2.89 minus 1. That gives us PC equals 0.7667. So the ratios of phthalic anhydride to glycerol to ethylene glycol is 1.5 to 0.8 to 0.5. Again, let's find out the functionality. For carboxylic group, it will be 1.5 times 2, which is 3. For glycerol, it will be 0.8 times 3, which is 2.4. And for ethylene glycol, it will be 0.5 times 2, which is 1. So the total hydroxy functionality is 2.4 plus 1, which is 3.4, and the carboxyl functionality is 3, so 3 is less than 3.4. So when we find R, we want to have the carboxyl functionality in the numerator and the hydroxyl functionality in the denominator, and we get a value of 3 over 3.4, which is 0.8824. Now let's find the weighted average functionalities. For carboxylic group, it would be 1.5 times 2 squared over 1.5 times 2. And for the hydroxyl group, it would be 0.8 times 3 squared plus 0.5 times 2 squared over 0.8 times 3 plus 0.5 times 2. So if we do the calculation, for carboxylic group, we get the weighted average is 2, and for the hydroxy group, the weighted average is 2.706. Plugging this into the Stockmeyer equation, we get 1 over square root of R, which is 0.8824, times 2 minus 1 times 2.706 minus 1. This gives us a PC value of 0.8150. So we have found out the PC values for the three scenarios that was given.